Hello everyone, hope you guys are doing good today. The data set that we have taken for this project is Paris housing price prediction, and this project was done by me and my friend Ketan Sri Kumapudi. The main reason that we have taken this data set is we want to create a best model which can predict the price of the houses in Paris. This best model helps the developer in determining the selling price of a house, and also it helps the customer to raise the right time to buy a house. Let's get into the topic. So as I said, the dataset that we have used here is a Paris housing price prediction, and the purpose is to predict the price of a house in Paris. So the tool that we have used here is the Excel Miner. As we all know, we can use it in RapidMiner. We can use RapidMiner as well, but we chose Excel Miner, and the algorithms that we have used here is the KNN and decision tree. Most of the people they want to buy a house in Paris, or it's a kind of investment for them for buying a new house or a second home, because everyone feels like Paris is a fashion capital, and people they feel like investing their money in Paris, and they want to get settled over there buying a new house. So based on all these things, we want to create the best model based on the attributes that we have got in this data set. So in our data set we have all numeric variables, so they are listed down here below. So the first one is the square meters, and the other one the number of rooms, because for predicting a house price, there are three factors in order to predict the price of a house. So they are the location, and the physical condition of the house, and the concept. So these three plays the major role. So the physical condition is nothing but whether the house internal condition is good or not, whether it is new build house, whether it has more number of rooms or not, and the location, the geographical location also plays a major role. So here are few of the attributes that we have got in this data set. As I said, the square meters, the number of rooms, and whether the house has a yard, whether it has a pool, and the number of floors, the city code, the zip code, and the city part range, and the previous number of owners for this house, and in which year this house was built, whether it is a new built one or whether it is old one, and whether the house has a storm protector, and the basement the basement square meters, and the attic square meters, which is nothing but the area below the roof, and the garage size, the storage room, and the guest room, like the number of guest rooms, and the price attribute, which is nothing but the predicted value in this data set. So let's move on to the next slide. So the data cleanup process. So as the data set that we have got here is a pure data set, because it doesn't have any unwanted columns, and after performing the missing handling data, we didn't find any deleted records. So hence this data set does not have any null values. So it's a pure data set. So moving on to the next slide, data exploration. So after doing the cleanup process, we have got the scatter plots that we have listed down here, and here all the variables are the good predictors, and the strong predictors here are the square meters and the number, and the weak predictors here is the nothing but the attribute which is the storage room. So we can see the scatter plots after performing all the steps. So the square meters, here we have the scatter plots for square meters, and the number of rooms, the floors, number of previous owners, the garage, and the storage room, and the guest room. And here are the observations and the city code here, and the number of floors. So based on all these things, we want to predict the best model by using all these variables. So moving on to the next slide. So the data mining techniques and the algorithms. So here we have we chose predict option to select our model, because we are predicting the price of the house. So the algorithms that we have used here is the logistic regression and KNN. So we all know the logistic regression is used when the dependent variable is categorical. So this logistic regression helps in finding the accurate results. So that we have, that's the reason we have taken this logistic regression, because we got the best R-square value after applying it on different models. So we have taken 3 models. So after applying it on the 3 models, we got the best. We have taken the best model which has the best R-square value here. And the other algorithm that we have used is the KNN algorithm. So this KNN algorithm is used for both the classification and regression, and it uses for finding the feature similarity to predict the values from any new points. And this KNN algorithm gives the K value, which helps in finding the best model. So let's move on to the next slide. So after model selection criteria, after using the 2 algorithms, the logistic regression and the KNN algorithm on the 3 models, for a logistic regression we have done partitioning for the first model is 60/40, and we have the R-square value for both validation and training for the 3 models. And for model 2 we have taken we have done partitioning for partitioning as 70:30, and the R-square value we have got for validation and training is almost the same. So for model 3 we have done partitioning, we have taken 80:20, and the same partitioning is done by using the KNN algorithm for the 3 models, and we have got K value as 5 for the model 1, and we have got the K value 7 for model 2, and we have got the K value as 9 for model 3. So based on the results that we have got after applying these 2 algorithms, we have chosen the best model. So moving on to the next slide, these are the graphs, decision trees that we have got after applying the 2 models. So we can see the decision trees here. And moving on to the next slide, model deployment. So model deployment is done by collecting the results and the results from the implementation model, so that this implementation model in the product environments helps us in picking up the best model. So based on the K values and K values that we have got up after applying the KNN algorithm, and the R2 values that we have got after applying the regression tree, we picked up the best model here. So in order to conclude, the algorithms that we have used in this data set has given us the best results for property researchers to use in housing price predictions. As we all know, all these data mining tools have their own limitations, so we have to be cautious on this. So In the next slide, I have provided all the reference links that I have used in this data set while working on this, after applying all the algorithms and predicting the and creating a best model which can predict the best prices for the houses. So all these links that I have provided here has helped me a lot in creating the best model. So thank you guys for giving me thank you professor for giving me this best opportunity, and thank you guys as well. I hope this presentation would be helpful, and thank you so much.